REST-based APIs. Applications use Application Programming Interface or APIs to communicate. To do so, one program can learn the variables and data structure used by another program, making logic choices based on those values, changing the value of those variables, creating new variables, and deleting variables. APIs allow programs running on different computers to work cooperatively, exchanging data to achieve some goal. In an API software world, some applications create an API with many other applications using or consuming the API. Software developers add APIs to their software so other application software can make use of the first application's features. When writing an application, the developer will write some code, but often the developer may do a lot of work by looking for APIs that can provide the data and functions, reducing the amount of new code that must be written. As a result, much of modern software development centers on understanding and learning new APIs, along with the available libraries, pre-built software that can be used to accomplish tasks rather than writing the equivalent from scratch. Several types of APIs exist, each with a different set of conventions to meet a different set of needs. In this video, we will learn about the representational state transfer or REST APIs because of its popularity as a type of APIs in networking automation application. This is the first major section of this video that we take a closer look at REST-based APIs. About a REST-based or RESTful APIs, we can say a REST APIs follow a set of foundational rules about what makes a REST API and what does not. First, from a literal perspective, REST APIs include the 6 attributes defined a few decades back by its creator, Roy Fielding. Those 6 attributes are client-server architecture, a stateless operation, clear statement of cacheable or uncacheable, uniform interface, layered, and code on demand. The first 3 of these attributes get at the heart of how a REST API works. In this video, I'm going to explain a little more about the first 3. Actually, until now we know that when you want to recognize one API is a RESTful or REST-based API or not, you can verify that these 6 attributes are available in that API. Okay, if you find one API with these 6 attributes, you can say that is a RESTful or REST-based APIs. Let me to explain a little about the client-server architecture, a stateless operation, and clear statement of cacheable and uncacheable for better understanding the REST-based or RESTful APIs. About the client-server architecture, like many applications, REST applications use a client-server architectural model. First, an application developer creates a REST API, and that application, when executing, acts as a REST server. Any other application can make a REST API call the REST client by executing some code that causes a request to flow from the client to the server. Let me to explain it in this figure. At step 1 here, you can see we have a REST client and here we have a REST server. Actually, the REST server is an application that has some APIs, application programming interface, and we can use these APIs to communicate with this application. Also here we have another application, and in this application we can create API call to connect to this API, and after that, for example, take some information from the REST server. This is the REST server, the intended application, and this is the REST client. First, let me to show you here the step 1. The REST client on the left executes a REST API call, which generates a message sent to the REST server. I will explain the detail of this message. In most cases, we are using the HTTP, and this is the HTTP that contain the message or the call of the API REST client, actually HTTP, TCP, and IP. I will explain the detail of it. And after that, at step 2, the REST server on the right has API code that considers the request and decide how to reply. And after that, at the step 3, the REST server sends back the reply message with the appropriate data variables in the reply message. Actually, we use the HTTP for sending our request and receiving the reply. We will learn about the reasons why we use the HTTP, but here until now we know that the HTTP is the selected protocol, choice protocol for sending our request to one REST server and receiving the reply with the HTTP include the data that we want. Actually, in this figure shows the use of HTTP. While many REST APIs use HTTP, the use of HTTP is not a requirement for an API to be considered RESTful. All right. We learned about the client-server architecture, the first criteria of the REST-based APIs or RESTful APIs. Now let me to explain about the second criteria, a stateless operation. The stateless attribute of REST APIs means that REST does not record and use information about one API exchange for the purpose of how subsequent API exchange are processed. In other words, each API request and reply does not use any other past history considered when processing the request. For comparison, the TCP protocol uses a stateful approach, whereas UDP uses a stateless operation. A TCP connection requires the endpoints to initialize variables on each end, with those variables updating over time, and with those variables being used for subsequent TCP messages. For instance, TCP uses sequence numbers and acknowledgement numbers to manage the flow of data in a TCP connection. But about the REST APIs, okay, this is a stateless, and here we don't have any information from previous, for example, API call. Here you can see the attributes of the stateless operation. No client state at server. Any state is maintained at client side, only at client side. Here on the server we don't have any state. Each request has all the information to process the, for example, request. Next attribute of REST-based APIs is clear statement of cacheable or uncacheable. To appreciate what is meant by cacheable, consider what happens when you browse a website. When your browser loads a new web page, the page itself contains a variety of objects like text, image, videos, and audios. Some objects seldom change, so it would be better to download the object once and not download it again. In that case, the server makes that object as cacheable. For instance, a logo or other image shown on many pages of a website would almost never change and would likely be cacheable. However, the product list returned in your most recent search of the website would not be cacheable because the server would want to update and supply a new list each time you request the page. REST APIs require that any resource requested via an API call have a clear method by which to mark the resource as cacheable or not. The goals remain the same: improve performance by retrieving resources less often cacheable. Note that cacheable resources are marked with a time frame so that the client knows when to ask for a new copy of the resources again. Alright, to appreciate a few of the upcoming topics, it helps to have a basic idea about how a programming language are use variables. Okay, because of that, here we are reviewing some type of variables like the simple variables, list variables, and dictionary variables. Let me to explain a little about the simple variables. Applications all process data with the same general actions, starting with some kind of input. The program needs data to process, so the input process reads files, sends database queries to a database server, or makes API calls to retrieve data from another application's API. The goal: gather the data that the program needs to process to do its work. Okay, programs then process data by making comparisons, making decisions, creating new variables, and performing mathematical formulas to analyze the data. All that logic uses variables. For instance, a program might process data with the following logic. If the router gigabit 00 interface has a configuration setting of switch port mode dynamic auto, then gather more data to ensure that interface currently operate a trunk rather than an, for example, access port. In programming, a variable is a name or label that has an assigned value. Okay, this is so important. In programming, a variable is a name or label that has an assigned value. To get a general sense for programming variables, you can think of variables much like variables from algebra equation back in the school. This example shows some examples of variables of different types in a Python program. The Python language is the most popular language today for writing network automation applications. These programs begins with the comment, the top 3 lines with triple single quotes, as you can see here. Sample program to multiply 2 numbers and display the result. Okay, this program begins with the comment and then create 4 variables, assigning them to different values, and print a line of output. The product is -12. Look at here. X equal 3, Y equal -4, Z equal 1.247, heading equal the product is, okay, and then print first the heading, after that the X multiply Y. The result is the process is, for example, -12. Let me to show you, this is the result of this program. Okay, as you can see, the variables in this example can be held at simple variables because each variable name has a single value associated with it. Simple variables have one variable name and one associated value, so they have a simple structure. Okay, as you here we have 3 simple or 4 simple variables: X, Y, Z, and also the heading. The values of simple variables can have a variety of formats. Okay, as you can see here, the example include variables that contain unsigned integers. This is X is unsigned integer, or signed integer. Y is unsigned. It has the value of unsigned integer actually. And here the Z has floating input numbers. Okay, and also here we have the heading. This is the text integer, text variable. As a summary, the variables in this example can be called simple variables because each variable name has a single value associated with it. Okay, it is so easy. And simple variables have one variable name and one associated value, so they have a simple structure. The values of simple variables can have a variety of formats include unsigned integer, signed integer, floating point numbers, and also text or heading. Now let me to explain a little about the list and dictionary variables. While simple variables have many great uses, programs need variables with more complex data structure. In programming, a data structure defines a related set of variables and values. For instance, Python uses list variables so that one variable name is assigned to a value that is a list of values rather than a single value. You could imagine that a network automation program might want to have lists, such as a list of device being managed, a list of interface on a device, or a list of configuration setting on an interface. First, consider the variable name list1 in this example. Okay, this is the list1. Note that the lines that begin with a number sign or pound sign are a comment line. Look at here. Variable list1 is a list in Python called an array in Java. List1 equal gigabit00 or G01, G02. This is a list variable. Even if you have never seen Python code before, you can guess at some of the meaning of the list1 variables. The code assigns variable list1 to a value that itself is a list of 3 text strings. Note that the list could include text, unsigned integer, and also signed integer, and so on. Okay. This figure, okay, the next figure shows the data structure behind variable list1 in actually the variable is assigned to the list, with the list having 3 list elements: G00, G01, and G02. This is the list1. Python supports a similar data structure called a dictionary. If you think of the contents of a dictionary for the English language, that dictionary lists a series of paired items, a term, and a matching definition. With programming language like Python, the dictionary data the structure lists paired items as well, keys like terms and values like definition. This figure, okay, it can show us the structure of the dictionary value matching the dict1 variable at the bottom of the example. Here you can see. Note that each key and its value is called a key value pair. Look at here. Key value, config speed, auto. Config duplex, auto. Config IP, 10.1.1.1. This is a dict1 dictionary variable. Look at here. Variable dict1 is a dictionary called an associative array in Java. Dict1 equal, okay, config speed, colon, value. This is key, this is value. Key value pair. Then config duplex, auto. Config IP 10.1.1.1. Okay, actually here we can see the key value pair. Alright, we learned about the simple variables, list variables, and also dictionary variables. Data structure can get more complex. Additionally, the data structure can be nested. For instance, a single variable's value could be a list, with each list elements being a dictionary, with the values in some key value pair being other lists, and so on. For now, be aware of the fact that programs use simple variables, but also use list and dictionary variables to make it easier to perform different kind of logic. Alright, now let me to explain about the REST APIs and HTTP. APIs exist to allow two programs to exchange data, you know it. Some APIs may be designed as an interface between programs running on the same computer, so the communication between programs happens within a single operating system. Many APIs need to be available to programs that run on other computers, so the API must define the type of networking protocol supported by the API. And many REST-based APIs use the HTTP protocol, but you know that it is not a requirement. The creators of REST-based APIs often choose HTTP because HTTP's logic matches some of the concept defined more generally for REST APIs. HTTP uses the same principles as REST. It provides with the client-server model, it uses a stateless operational model, and it includes headers that clearly mark object as cacheable or not cacheable. Okay. It also includes verbs, words that dictate the desired action for a pair HTTP request and reply, which matches how application like to work. I will explain them. Okay. First, let me to explain a little about the HTTP. Okay. And after that, we can talk about the relation between the HTTP and REST APIs. HTTP defines the concept of an HTTP request and reply, with the client sending a request and with the server answering back with a reply. Each request and reply lists an action verb in the HTTP request header, which defines the HTTP action. The HTTP message also includes a URI or URL which identifies the resource being manipulated for this request. As always, the HTTP message is carried in IP and TCP with headers and data as represented in this figure. Let me say to get some perspective about HTTP, ignore REST for a moment. Whenever you open a web browser and click a link, your browser generates an HTTP GET request message, similar to, for example, this figure, and the message includes an HTTP header with the GET verb and the URI. It means that here we have the verb of get, means I want to receive, for example, one file and or one URI, and here you will see the URI, the address of the, for example, that we want to receive, uniform resource identifier or uniform resource locator. Okay, this is the content of the HTTP request. And you know that the resources returned in the reply are the component of a web page, like text file, image file, and also video files. Alright, now let me to explain about the software CRUD actions. Okay, it is a famous name in the industry of the, for example, application or programming. Let me to explain about it. The software industry uses a memorable acronym CRUD or CRUD for the 4 primary actions performed by an application. Those actions are create, read, update, and delete. You will learn more than this about it, but for now let me to say that create means allows the client to create some new instances of variables and data structures at the server and initialize their values as kept at the server. It means that we can create one variable, one for example data structure, and after that we can give the values for that variable or the for example data structure. Then read allows the client to retrieve or read the current value of variables that exist at the server, storing a copy of the variables, structures, and values at the client. Update allows the client to change or update the values of variables that exist at the server. Delete allows the client to delete from the server different instances of data variables. For instance, if using the northbound REST API of a DNA controller, a Cisco Software Defined Access or SDA, you might want to create something new, like a new security policy. From a programming perspective, the security policy exists as a related set of configuration settings on the DNA controller, internally represented by variables. To do that, a REST client application would use a create action, okay, using the DNA Center RESTful APIs then or that created variables on the DNA controller via the DNA Center REST API. The concept of creating new configuration at the controller is performed via the API using a create action per the CRUD generic acronym. Other examples of CRUD action include a check of the status of that new configuration, a read action, an update to change some specific setting in the new configuration, an update action, or an action to remove the security policy definition completely, a delete action. HTTP works well with REST in part because HTTP has verbs that match the common program actions in the CRUD paradigm. Okay, this table, okay, lists the HTTP verb and CRUD terms for easy reference and study. Look at here, we have the some actions for action: create, read, update, and delete. Create new data structure and variables. CRUD term is create. HTTP verb is post. Read or retrieve variable names, structures, and values. In CRUD we say read. In HTTP we have the verb of get. Update or replace values of some variables, we call it update in the CRUD term, and in HTTP we say patch or put. Delete some variables and data structure, in both CRUD and HTTP we say delete. While this table lists HTTP post, okay, as a create action and HTTP patch and HTTP put as CRUD update action, All three of these HTTP verbs means the post and also patch and put verb might be used both for create and for update action in some cases. This is beyond the scope of our course, but now we can understand why we use HTTP for RESTful APIs, because it has compatibility with the CRUD terms create, read, and update and delete, and in HTTP we have verbs for these functions. Now let me to explain about using URIs with HTTP to specify the resource. In addition to using HTTP verbs to perform the CRUD function for an application, REST uses URIs to identify what resource the HTTP request acts on. For REST APIs, the resource can be any of the many resources defined by the API. Each resource contains a set of related variables defined by the API and identified by a URI. For instance, imagine a user create a REST-based API. When she does so, she creates a set of resources that she wants to make available via the API, and she also assigns a unique URI to each resources. In other words, the API creator create a URI and a matching set of variables and defines the action that can be performed against those variables, read, update, and so on. The API creator also creates API documentation that lists the resources and the URIs that identifies each resource. Among other details, the program for a REST client application can read the API documentation, build a REST API request, and ask for the specific request, as you can see in this figure. Here, for example, we send HTTP GET, and the URI is URI3. URI3 is one of the URIs, is one of the resources that is available with include multiple variables and values that the application programmer give us. Okay, actually the application programmer defines some URIs for reaching to their different resources in the REST server. Okay, this figure shows the URIs as generic values. Okay. However, today's network engineers need to be able to read API documentation, see URIs in that documentation, and understand the meaning of each part of the URI. This figure shows a URI specific to the Cisco DNA Center northbound REST API as an example of some of the components of the URIs. Let me to explain a little about them. First, HTTPS. The letters before the colon / identify the protocol used. In this case, HTTP secure, which uses HTTP with SSL encryption. After that, here we can see the DNAC, means DNA Center.example.com. This is the host name or address. This value sits between the / and or double slash, and after that one slash, and identifies the host. If using a host name, the REST client must perform name resolution to learn the IP address of the REST server. After that, here you can see the third part, the path or the resource that we want to, for example, take information from this resource. This value sits after the first / and finishes either at the end of the URIs or before any additional field like a parameter query field. HTTP calls this field the path. Okay, but for use with REST, the field uniquely identifies the resources as defined by the API. To drive home the connection between the API, URI, and resource part of the API, it can be helpful to just a general tour of the API documentation for any REST-based APIs. For instance, when Cisco created DNA Center, it creates the REST-based northbound interface and choose one URI, as you can see here. Okay, and this figure shows a copy of the doc page or documentation page for that particular resource for comparison. Okay, continue to search for yourself to see more examples of the resources defined by the Cisco DNA Center API. Many of the HTTP request messages need to pass information to the REST server beyond the API. Some of that data can be passed in header field. For instance, REST APIs use HTTP header fields to encode much of the authentication information for REST calls. Additionally, parameters related to REST call can be passed as parameter as part of the URI itself. For instance, the URI that we can see here, ask the Cisco DNA Center for a list of all known devices, with Cisco DNA Center returning a dictionary of values for each device. You might instead want the dictionary of values for only a single device. The Cisco DNA Center API allows for just that by tracking on the following to the end of the URI. For example, you can add a value like this value at the end of URI to receive information only for one device, okay, one specific device. Look at here, management IP address, this IP address, and MAC address, this MAC address. Here you can see the general term for requesting a specific information for one device. Look at here, host name, my host, management IP address, this management IP address, and also, for example, we can use MAC address. Actually, this figure summarizes the major component of the URI commonly used with a REST API, with the resource and parameter parts of the URI identifying specifically what the API should supply to the REST client. Alright, now let me to pull some of the REST API concept together with one example of REST API call to DNA Center for a bit of development perspective. When working to automate some part of your network operations task, you would eventually use a program that made API call. However, early in the process of developing an application, you might first focus on the data available from the API and ignore all the programming detail at first. API development environment let you focus on the API calls. Later, the same tool can typically generate correct code that you can copy into your program to make the API calls. The examples in this part use an application named Postman. Postman can be downloaded from free www.postman.co and used as you can see here. Note that Cisco DevNet makes extensive use of Postman in its many labs and examples. The first example here can show us a screenshot of a part of the Postman application after it sent a REST client GET request to a DNA Center REST API. Actually, with Postman, we are creating API call, and after that we receive many information. Okay, let me to show you or explain some of this information. Here you can see the URI. The URI near the top lists a host name of sandbox, for example, nac2.cisco.com. as you can see, which is an always on DNA Center instance supplied by Cisco DevNet site. Okay, the resource part of the URI, as you can see here, shows the same resource listed earlier in the previous pictures, asking for a list of devices. And after that, the bottom center of the window shows the data returned by the DNA Center REST HTTP GET response, and at the middle right, it lists the GET response a status code of 200, meaning, okay, this is one of the codes that we have in the HTTP. In the future videos, we will work with the Postman and we will learn about it with more detail. Here only, I want to show you one simple example that when we create API call with some API testing and automation programming, like programs like the Postman, we will receive information that can be provided from the APIs or REST-based APIs that we have in the, for example, destination application, okay, or destination controller. Here we connected to the DNA Center, and after that we requested that I want to receive, for example, the network devices information, and as you can see with a status code of OK, we received this information. Now take a moment to look through the data at the bottom of the Postman window that we can see here. The text follows a data modeling format called JavaScript Object Notation or JSON. We will learn about the JSON with more detail in future, but for now we know that this is a data modeling format. Okay, actually we know about the JavaScript Object Notation or JSON, which is one of the main topics that we will learn about it in this video. However, armed with just a knowledge of routers, you can find a few facts that look familiar to help you see the text. Okay, as you can see here, this is a JSON code. We can view some of the JSON output in that window, just so you can see the format and some of the data returned in this single API call. Okay, look at here. Response include, this is the JSON format. I will explain the detail of the JSON, but here you can see a curly bracket and then a colon. Here we see response, then colon, again one curly bracket, type, this is the key value pair, type, and then value, key value, and so on. Here we can see the information that we received in the HTTP response from the DNA center. Actually, API development tools like Postman help you work out the particular of each API call, save the details, and share with other engineers and developers. Eventually, you will be ready to make the API call from a program. With a simple click from the Postman UI or user interface, Postman supplies the code to copy paste into your program so that it returns all the output shown in the center or bottom of the window back as a variable to your program. By now, you have a good foundation knowledge of the mechanics of REST APIs. By learning some skills and using the API documentation for any REST API, you could now experience or experiment with and try to make REST API calls. For many of those, the data will return to you as text, often in JSON format. So the next part of this video examines the meaning of the, for example, this text. Alright, now let me to explain about the data serialization and JSON. In your journey to become a modern network engineer with network automation skills, you will learn to understand several data serialization language. Each data serialization language provides methods of using text to describe variables with the goal of being able to send that text over a network or to store that text in a file. Data serialization language gives us a way to represent variables with text rather than in the internal representation used by any particular programming language. Each data serialization language enables API servers to return data so that the API client can replicate the same variable names as well as data structure as found on the API server. To describe the data structure, the data serialization language includes special characters and conventions that communicate ideas about list variables, dictionary variables, and other more example or more complex data structures. Here I'm going to explain the concept of data serialization language with a focus on the one data modeling language that we should learn about it, JavaScript Object Notation or JSON. Alright, now let me to explain about the need for a data model with APIs. This figure shows how to move variables in a program on a server to a client program. Actually, first we will learn about the non-working example, and after that we will explain about the need for a data model. As you can see here, for the non-working example, consider the flow and number the steps in this figure. A REST client sits on the left, and the REST client asks for resources and the server needs to reply. In REST, as a resource is a set of variables as defined by the API, so the REST server needs to return a set of variables to the REST client on the left. The steps in this figure run as follows. First, or 1, the REST server, a Java application, as you can see, takes a copy of the stored variables in RAM in response to the REST request. This is the first step. The REST API code creates the REST reply and sends it over the network, placing an exact replica of what the REST server had in RAM to respond or to represent the variables in that resource. Actually, we sent previously one request, or we created API call, and now the variables with the, for example, API created and received, and after that it will send with the HTTP response to the client. Okay, now in step 3, the REST client, a Python application, receives the REST reply message, storing the exact same bits and bytes into its RAM in an attempt to have a copy of the variables data and data structure on the server. Actually, the REST client is a Python program and the REST server is a Java program. Okay, the process that we can see in this figure does not work, and it is not attempted because the REST client program may not store variables in the same way. First, programs written in different language use different conventions to store their variables internally because there is no standard for internal variable storage across languages. In fact, programs written in the same language but with different versions of that language may not store all their variables with the same internal conventions. To overcome this issue, applications need a standard method to represent variables for transmission and storage of those variables outside the program, and data serialization language provide this function. Now this figure shows the correct process flow in comparison to previous figure with the data serialization process included. Step 1. The server collects the internally represented data and gives it to the API code. Step 2. The API converts the internal representation to a data model representing those variables with JSON, as you can see here. Actually, now we created the variables to the JSON string. Step 3. The server sends the data model in JSON format via message across the network. And step 4. The REST client takes the received data and converts the JSON formatted data into variables in the native format of the client application, for example, the Java application. It means that at the end of the process, the REST client application now has equivalent variables to ones it's requested from the server in the API call. Note that the final step to convert from the data serialization language to the native format can be as little as a single line of code. Okay. Finally, note that while data serialization language like JSON enable application to exchange variables over a network, applications can also store data in JSON format. Alright, now let me to explain about the data serialization language. You will hear about and eventually use several data serialization and data modeling language to more you learn about the network automation. Okay, about the JSON we will learn with more detail in this video, but I'm going to review some of the other data serialization language here. These different data serialization language exist to meet different needs that have arisen over the, for example, years. JSON or JavaScript object notation attempts to strike a balance between human and machine readability. Armed with a few JSON rules, most humans can read JSON data, move past simply guessing at what it means, and confidently interpret the data structure defined by the JSON data. At the same time, JSON data makes it easy for program to convert JSON text into variables, making it very useful for data exchange between applications using APIs. You can find the detail of JSON in IETF RFC 8259 and in number of sites found with the internet search, including www.json.org. We will learn about the JSON with more detail in this video. Now let me to explain about the next data serialization language or data modeling language, eXtensible Markup Language or XML. Back in the 1990s, when web browsers and the World Wide Web www were first created, web pages primarily used hypertext markup language or HTML to define web pages. As a markup language, HTML defines how to add the text or a web page to a file and then add markup, additional text to denote formatting detail for the text that should be displayed. For instance, the markup include codes for heading, font type, size, colors, hyperlinks, and so on. The eXtensible markup language or XML came later to make some improvement for earlier markup language. In particular, over time, web page became more and more dynamic, and to make the page dynamic, the file needed to store variables whose values could be changed and replaced over time by the web server. To define variables to be substituted into a web page, the Word needed a markup language that could define data variables. XML defined a markup language that has many features to define variables, values, and data structure. Over time, XML has grown beyond its original use as a markup language. XML's feature also make it a useful general data serialization language, and it is used as such today. Comparing XML to JSON, both attempts to be human readable, but with XML being a little more challenging to read for the average person. For instance, like HTML, XML uses beginning and ending tags for each variable, as you can see in this, for example, figure. In the highlighted line, as you can see here in this example, the MAC address, tags denote a variable name. With the value sitting between the tags, as you can see, look at here, that this is the tag MAC address, and again here MAC address, and this is the value. Actually, in XML, in each line we have tag at the beginning and at the end of the line, and after that we will have the value between these two tags. We will learn about the XML in future videos and future courses. Here only we are reviewing the eXtensible markup language. Until now we learned about the JSON and also XML. Let me to explain about the YAML. YAML is the abbreviation of the YAML ain't markup language. Has a clever recursive name, but the name does tell us something. YAML does not attempt to define markup detail while XML does. Instead, YAML focuses on the data model or structure detail. YAML also strives to be clean and simple. Of the data serialization modeling language listed here, YAML is easily and easiest to read for anyone new to data models. Ansible is one of the applications that we will learn about it in future videos, makes extensive use of YAML files. This example shows a brief sample, and to make the point about readability, even if you have no idea what Ansible does, you can guess at some of the functions just reading the file. Note that YAML denotes variables in double curly bracket, as you can see here. Look at here, this is a for example, text. This comment line, the comment actually is a place to document this playbook. Name, a colon, get iOS facts, host, colon, MyLab, and then variable CLI, host, then here we have some variables, Ansible host, username, then username, password, then password. Actually, as you can see, YAML denotes variables in double curly bracket, as you can see here. We will learn about the Ansible with more detail in future videos. Alright, this table summarizes the data serialization language mentioned in this video, JSON, XML, and YAML. Let me to review about them, or let me to compare them. About the JSON, this is the abbreviation of JavaScript object notation. About the XML, this is the abbreviation of eXtensible markup language. And about the YAML, this is the abbreviation of YAML ain't markup language. About the origin or definition, JSON is, for example, JavaScript or JS language, RFC 8259. About the XML, the origin is World Wide Web, for example, or w3c.org. About the YAML, this is the origin is YAML.org. about the central purpose, JSON, general data modeling and serialization, XML, data-focused text markup that allows data modeling, about the YAML, general data modeling. About the common use, JSON can use in REST APIs, XML in REST APIs and web page, and YAML in the Ansible application. Alright, in this section I'm going to explain about the interpreting the JSON. You can think of that skill and task with two major branches. First, even ignoring the syntax and special characters, anyone who knows the topic can probably make intelligent guesses about the meaning of many of the key value pairs. For example, without knowing anything about the JSON syntax, you could probably determine from your prior knowledge of Cisco routers and switch that JSON in this example lists two devices. Okay, maybe their host names and a list of interfaces on each device. Honestly, you probably already know everything needed to do this kind of intelligent guessing. However, to perform the second type of task where you analyze the JSON data to find the data structure, including objects, lists, and key value pairs, you need to know a bit more about JSON syntax. Okay, because of that, in this section of the video, I'm going to explain about the interpreting JSON. Here, as you can see, we have R1. This is the router 1, for example, the host name of the first router. And here we can see the name of interfaces, gigabit 00, gigabit 01, gigabit 0, for example, 2, 0, and also the R2 with its interfaces. First, consider these rules about key value pairs in JSON, which you can think of an individual variables names and their values. Key value. Look at here. Here we have multiple key value pairs. Each and every column identifies one key value pair with the key before the column and the value after the column, as you can see here. About the key, it can be text inside double quotes before the column, used as the name that references a value. Actually, now we know about the key between two quotes, okay? And after that, as you can see, this is a text that it can be referenced as a value. After that, we have the value itself. Value, the item after the column that represent the value of the key, which can be text, or which can be numeric, or which can be array or object. About the text, listed in double quotes. About the numeric, listed without quotes, you will see it. And after that, about the array, a special value. And about the object, again, it can be a special value. Let me to write here. I will explain each of them in the next section, but for now, let me to say that value can be text. Here we can see the text listed in double quotes, and also it can be numeric. And when you have numeric value, it listed without quotes. I will show you. And after that, it can be array, okay? And after that, it can be object. Okay, because of that, now we know about the key and value. And also we can have multiple pairs, as you can see here. When listing multiple key value pair, separate the pairs with a comma at the end of each pair. As you can see here, we have a comma at the end of each pair, except the last pair. Look at here, key value, then comma, key value, then comma, and finally key and value. Okay, to work through some of these rules, we can consider this example focusing on the three key value pair. As an approach, just find each column and look for the quoted string just before each column. Those are the keys, okay? First best, second best, and third best. Then look to the right of each column to find their matching values. You can know all three values are text value because JSON lists the values within double quotes. Because of that, they are text. As for other special characters, note that the commas and the curly brackets, the first two key value pair and end with a comma, meaning that another key value pair should follow. The curly brackets that begin and end the JSON data denotes a single JSON object, one pair of curly brackets, okay? JSON files and JSON data exchange over an API exist first as a JSON object with an opening left and closing right curly bracket, as you can see here. Here we can see the opening curly bracket, key value, comma, key value, comma, key value, comma, and finally here, as you can see, we have the closing curly bracket. This is the one JSON object, or one JSON, for example, dictionary with three key value pairs. Now let me to explain about the interpreting JSON object and arrays. To communicate data structures beyond a key value pair with a simple value, JSON uses JSON object and JSON arrays. Objects can be somewhat flexible, but in most uses, they act like a dictionary. Arrays list a series of values. I will explain them, don't worry. Python, the most common language to use for network automation, convert JSON object to Python dictionaries and JSON arrays to Python list. For general conversation, many people refer to the JSON structure as dictionaries and a list rather than as object and arrays. Okay, to begin, consider this set of rules about how to interpret the syntax for JSON object and arrays. First, object, a series of key value pair enclosed in a matched pair of curly brackets with an opening left curly bracket and its matching right curly bracket. Also array, I will show you. A series of values, not key value pairs, enclosed in a matched pair of square brackets, okay, with an opening left square bracket and its matching right square bracket. Also, key value pair inside object. All key value pairs inside an object conform to the earlier rules for key value pairs, and also values inside arrays. All values conform to the earlier rules for formatting values, okay? For example, double quotes around text, no quotes around numbers. This example, as you can see, shows a single array, okay, in JSON format, because it started with the left and right bracket, okay, not curly bracket. Also, notice that the JSON data begins with a opening bracket and then lists three text value. The value could have been a mix of values, or for example, it can be text, it can be for example, a string or numbers or some other things, okay? And it then ends with the closing bracket. Because of that, this is an array, and as I mentioned before, we have some values inside of arrays. All values conform to the earlier rules for formatting values, for example, double quotes around text, no quotes around the numbers. Also, this example shows only the array itself. JSON arrays can be used as a value in any key value pair. This figure does just that. It's shown in a graphic to allow easier highlighting of the arrays and object. The JSON text in the figure includes two arrays, as you can see, or two lists as values, each found just after a colon, indicating they are values. Look at here, JSON object with two key value pair. You know that in JSON object that we learned about it, we have a series of key value pair enclosed in a matched pair of curly brackets with an opening left curly bracket and its matching right curly bracket. Here we have exactly the same condition. As you can see, we have an opening curly bracket and closing curly bracket, and here, as you can see, we have key value pair. But in the key we have favorite pliers. In the value, as you can see, we used a JSON array. And here, for example, favorite pliers with three values. This is the array, started with a bracket and ended with another bracket. Also here we have another key value pair. Instead of value, okay, or simple value, we use the JSON array. No, Think about the entire structure of the data in this example. It has a matched pair of curly brackets to begin and end the text, encapsulating one object inside of it. Okay, we can say it encapsulating one object. You know that with curly bracket we identify the objects. Okay, that object contains two columns, so there are two key value pair. You know that each column means one key value pair. Okay, inside the object. When you think about the broader structure, as you will see in the next picture, this JSON file has one JSON object itself with two key value pair. As you can see here, we have one JSON object, include two key value. This is two key value, favorite players, and then the list. Okay, as you can see here. And after that, here we have the next, for example, key value. Instead of the value, we used array. Actually, we can say inside of the key value, we can use simple value or we can use array as the value. Alright, to drive home the idea of how to find JSON object, consider the example in this figure. This figure shows correct JSON syntax. It has the following. First, there is one object for the entire set because it begins and ends with curly brackets. As you can see, here we have the one opening curly bracket, and here we have one closing curly bracket. Because of that, we have the one JSON object here. Also, as you can see, the outer object has two keys. Okay, the first is Vandals favorites, and the second is the interface config. Why? Because here we have two column. Okay, the first column and the second column. After that, the value of each key value pair is another object, each with curly brackets and three key value pairs. Look at here. For example, instead of the value, here we use one other object. This is the nested object. Player, Messi. Team, Barcelona. League, La Liga. Then interface config, IP address, and after that the for example value, and after that IP mask, value, speed, value. What does it mean? It means that inside of one object, okay, you know that inside of each object we have some key value pairs, but for key and value, instead of the value you can use simple value, you can use for example array, or you can use the other object. The JSON example in this figure shows how JSON can nest objects and arrays. That is, JSON puts one object or array inside another. Much of the JSON output you will see as you learn more and more about the network automation will include JSON data and nested arrays and objects. Alright, now let me to explain about the minified and beautified JSON. So far, all the JSON example shows lots of empty space. JSON allows for white space or not, depending on your needs. For humans, reading JSON can be a lot easier with the text organized with space and aligned. For instance, having the matched opening and closing brackets sit at the same left offset makes it much easier to find which brackets go with which. Okay, when stored in a file or sent in a network, JSON does not use white space. For instance, earlier in this section, we saw this example, okay, showed one JSON object with three key value pairs with white spaces, okay, taking 5 lines. However, stored in a file or sent over a network, the JSON would like the following, this, okay. And most of the tools you might use when working with JSON will let you toggle from a pretty format, good for human, to a raw format, good for computers. You might see the pretty version literally called pretty or beautified or spaced, while the version with no extra white space might be called minified or raw.